Hi, I'm Bob Tabor with LearnVisualStudio.net. We are in lab number 5, Process Lifetime Management, and the lab does a really nice job of explaining the ramifications of the suspending event sent by Windows 8 to your app. I wanted to take a few moments and talk about the entire lifetime of your app, what triggers a suspend and a termination, and so on. And so let me start off by saying that there's a fundamental change in how apps are terminated with the arrival of Windows 8. In previous versions of Windows, the user decided when to terminate an app. You would just hit the quit from the menu or the little red X in the upper right-hand corner. You could have multiple apps open at the same time, usually referred to as multitasking, each consuming a little bit of your computer's memory and processor resources. And if you open up enough apps, eventually you would begin to run low on memory, and so the system would try to help you out by taking information from memory, from RAM, and then caching it to disk for those apps that weren't in the forefront. And so you'd hear your hard drive churning in the background. That's because Windows is trying to kind of juggle what's currently in your RAM and what's currently being cached on your hard drive. But eventually, your entire computer would bog down, all right? So in Windows 8, at least for Windows Store apps, Windows itself is in control of when to terminate an app. Each app runs full screen unless, of course, you're in snapped or filled mode, but let's just focus on full screen mode for the moment. So a user launches your app, and then they work in it for a little while, and then they decide to go to the start screen and open up a second app. At that point, Windows takes your app, kind of puts it in suspended animation in a state called suspended, and at that point, your app has an opportunity to save off any information that's important to it before launching the other app. Now, your app is still running in the background, but it's not currently processing any information. It's not executing any code. It's just, again, put on ice for a little while. And now let's suppose that the user switches to a third app, brings it up, the second app is put in suspended mode, and then a fourth app, and then a fifth app, and then a sixth app. So you've got all of these apps that have been suspended in Windows memory. And eventually what will happen is if the user opens up enough apps, Windows becomes under or memory pressure. And so then when Windows needs more memory, it'll begin to terminate these apps and just eject them and remove them from memory completely. So what if your app is in a suspended state and the user decides to switch back to it? Well, Windows 8 will unsuspend it. The memory footprint is still intact, and the app's threads of execution can begin to use the CPU again, and so they can access the file system, the network, and so on. So let's just get clear on exactly what we mean by the terms suspended, resume, and terminate. When an app is suspended, its memory footprint, so its variables, its threads, are not allocated any CPU cycles, and there's no access allowed to the disk or the network. When an app resumes, it's coming out of suspended state prior to being terminated. Terminated means that the app has been completely removed from the computer's memory. So what does that really mean? Now the memory footprint can be reclaimed by Windows 8 for optimization purposes or allocation to new Windows Store apps that are being launched. Now, if the user wants to launch your app again at some point in the future, they'll have to relaunch it, which means it'll need to reinitialize everything. Variables, classes, everything will be reinitialized, and we'll start from the very first lines of code and begin an execution path from there on down. All right? But most importantly, the app is not given a notification that it's being terminated, only that it's being suspended. Okay? So up to now in the Contoso Cookbook, we've been using the Grid App template, and the Grid App template takes care of the initial setup that gives you basic PLM, Process Lifetime Management features, and you can extend it, and we're going to see a few points of extension a little bit later in this lesson. So for now, though, let's take a look at the default.js file, and there's actually two spots where this comes into play. If you take a look at line number 12, we're looking for this activated event, and we're going to add an event listener for the activated event. When it happens, we fire off all this. And this you can see happens in one of two moments, either when the application has been newly launched or whenever it's been reactivated from suspension. And then there's also this on checkpoint, and we are merely, and we'll get back to this line of code, but basically we're just taking whatever's currently in the navigation history and saving it off so that when the app is brought back from suspended animation, so to speak, that we can regain all of that navigation history. But as you can see here, the application is about to be suspended. It gives us an opportunity to handle this event and write any code to save off important information. All right. So if we bump back up here, you can take a look and see that here we're checking for the previous execution state and making sure that it's not been terminated. So previously we were not terminated. If we were terminated, then we'll run this section of code. If not, then we'll run this section of code. And so you might wonder, well, what are the other application execution states? And this is where the help can come in handy. I'm looking at this application execution state enumeration. The link for this should be on the same page wherever you're streaming this video from or where you originally downloaded it from. And you can see the various settings that are available: not running, running, suspended, terminated, and closed by user. So for example, if you had some doubt in your mind, for example, what's the difference between not running and terminated? Well, you can see the difference is the app currently is not running. Maybe it's never been run, or it hasn't previously been terminated. Or terminated is the app was terminated after being suspended. So a little bit different of a state there. And so it's a nuance, but it's a difference nonetheless. And it's something, if we ever needed to know that in the future, we'd be able to get at it. But take a look. Back in line number 14, here we're making sure that if the previous execution state was terminated, then we'll execute again this block of code, otherwise execute this block of code. We would write code here to initialize the app if it has been newly launched, or restore the app if it's been reactivated from suspension. But as the Hands-On Labs explains, in our case, the only real state information that we need to be concerned with is which page the user was on prior to suspension. So if we look at the on checkpoint event handler here in line number 41, we can see that this line of code is called prior to suspension. Therefore, we save the navigation history into something called session state.history. When we come out of suspension in line number 22, now not only the last page that the user was on is restored, but all the pages prior to that in the history have been restored as well and put back into the navigation's history. All right. And so what happens behind the scenes is that, especially if there's a termination involved, all that information is saved into a JSON file in a file that's called sessionstate.json. Now, just for my own curiosity, I wanted to see this at work and how this actually operated. I'd like to figure out how to get my app to simulate the process of suspension and termination so that I could see this file printed out on my own. Otherwise, I'll never get to kind of intercept it and look at it. So Visual Studio provides this feature. What you need to do is first make sure you're running on local machine. And now let's navigate to a page like Quiche Lorraine. And what I'm going to do at this point, after I've navigated just a tiny bit, go back to Visual Studio, and I'm going to look at this suspend button. Now there's three things I can do. I can suspend, resume, or suspend and shut down. I'm going to choose that last option, suspend and shut down. So that is basically putting our app under memory pressure and allowing Windows to terminate it, right? Except we're telling it to just take those actions for us. So now what I want to do is look for that JSON file. And you might be tempted to say, well, it saves everything else in the projects folder, Contoso Cookbook, and you can kind of look in the bin directory and look around, but you're not going to find that file there. Actually, you have to hunt around a little bit for it. It's in your users folder, so C:/users/Robert. App data is a hidden folder, so you're going to have to make sure to set your options for the Windows Explorer so that you can see all folders, including hidden folders. So here we are in app data, local, packages, and then there are a bunch of these package names Some of them have names and some of them just have GUIDs. What I found to be the easiest thing to do is just to sort by date modified. And so you can get at the ones that have been just recently modified. I just happen to know that this is the one that we're looking for here. And let's look for local state. And there we go. There we are, sessionstate.json. And let me do this. In Windows, I'm going to hit the Win key plus F to bring up search. And I'm going to type in Notepad and then go up, use the Tab key to get to the selection type. I'm going to select for apps. And then since Notepad is highlighted, I'm going to hit the return key on my keyboard again. And I'm just going to drag and drop this JSON file in here. And we can look at this. I wish I had it a little bit better formatted, but this is essentially just what gets output from that on checkpoint event handler. It creates this JSON file. And so we can look at the backstack, the various pages that have been visited prior to us exiting out, the current page that's being viewed, including which item was currently selected, the quiche, and it also has a forward stack, but since we haven't gone to pages and then come back to the current page, that doesn't have any data in it right now. But at any rate, that's how it all kind of works under the hood. This is just a serialized version of the history object. It's the last page that we navigated through along with some of the other details of the navigation history, and so it uses this so it can rehydrate that object that we'll ultimately use for our nav object. Now, opening up the file that's kind of working behind the scenes, if I ever get that opportunity, it always helps me understand what's going on under the hood. And I can see that this is just a dehydrated version of the actual object that's in memory that represents navigation. Okay, so that's cool. And the great thing about this is that we can easily extend what data is being stored and restored here in our on checkpoint and then restored here in our activated event handler. And so to kind of demo this, I found a great example here in on MSDN. It's called App Activate and Suspend using WinJS sample, and there should be a link for this on the page where you're currently streaming or originally downloaded this from. And so I downloaded this and I unzipped it to this let's see, where did I put it? Activate folder, and in the JavaScript subdirectory, I'm just going to open up the solution file and run it. And I'm just going to go ahead and just run it for the very first time, and you can see how this works. There are two text boxes here, and I can put in my name, and then before I do anything else, I'm going to go just like we did before, and I'm going to choose Suspend and Shut Down in Visual Studio. And now I'm going to rerun the app, and notice that it's saved off custom values. In this case, first name and last name into that that JSON file for reactivation the next time that we accessed it. And if you take a look in the activation.js file, which should be in this JS folder next to our default.js, there's an activation.js. You can see what they did here. So here they have a different way of handling the checkpoint, but essentially what they do is create a person object and then retrieve the values of the text boxes that have the ID of first name and last name, and then they set that person object to the session state.person. So you can save lots of different objects in session state, not just one at a time. Here they just dynamically added on the person and set it equal to this person object that got populated. And then during the processed event, it says during an initial activation, this event is called before activation completes. Do any initialization work that's required here. So here they just make sure that there's something inside of that person object, and if there is, they just retrieve it out and set it equal to put it into the text boxes that have the ID of first name and last name by setting the value attribute. Okay? It's as easy as that. And you can use this as a template in your own apps if you want to enable that feature. Very cool. All right. One last thing. You want to keep in mind that your app has about 5 seconds to get its work done once it receives the suspending event from Windows. So during that 5-second window period of time, the user could hop out to email for a quick check and then back into your app. So no real work would be necessary on your part. The app could just continue on as if nothing happened since it was never officially suspended. And whatever work it did when it received the suspending event shouldn't be harmful to the app in any way. So no harm, no foul. So just be aware of that you have a 5-second window where somebody could switch out and switch back in. And even though your suspending event has been called, essentially you can handle it. You just don't want to do anything destructive during that period of time. Just save stuff and then your application should brace itself for being put on ice for a few minutes, okay? Or permanently. Okay, so in this lesson, we learned more about how Windows 8 manages the lifetime of our apps processes. We learned about the checkpoint event and the session state object and how it takes care of the details of serializing our app state into JSON. We looked at that JSON file. That was kind of neat. We saw how to extend this functionality in order to save off form data or any information that our app needs, any stateful information that would help the user experience the app once you bring it out of suspended state in the form in which they last were working in it. So that's a very helpful feature, especially for the user. Okay, so we're going to continue on to lab number 6 in the next lesson. We'll see you there. Thank you.